PCG Grammar on its surface seems relatively simple. The syntax isn't very hard. It has nodes to help you with it, but once you start trying to set it up yourself, you realize some things are not as straightforward as they appear to be on the surface when you first take a look at it. I'll be showing you guys how to create this setup where all of the pieces here are maintaining their original height. If I drag this out, you can see it is exactly the right height of the original mesh. Or if I want to, I can disable the original height, and now I can go ahead and customize how tall I want these to be. I can specify I want these to be considerably taller. I can shrink the middle gate. I can raise the posts. I can do whatever I'd like. And I can overall scale the entire thing using module height effectively. And if needed to, I can flip the direction of these to go in the other way in case I am using a mesh with a back that isn't there. So one-sided mesh. But a quick note about this tutorial, it does assume you have a basic understanding of grammar syntax, because I'm not going to be covering the syntax of grammar in this video. I did make a previous video for grammar, which you can check out right here, going over the syntax and explaining in general what grammar is and how it works. So you might want to check out that video before watching this potentially. But with that out of the way, let me show you how to create this. To get started with PCG, just go to Edit and Plugins and make sure PCG is turned on by searching PCG and turning on the Procedural Content Generation Framework, PCG, and restart your engine as needed. To do this, we're going to need two things. Of course, we're going to need the PCG graph. I'll call this PCG fence, and we'll need a blueprint class actor, because that is where we're going to house the spline for it. So I'm going to call it BP_fence. And then I'll go ahead and open the blueprint. And we'll add a spline component to this. We don't need to do anything aside from just adding it. It could be nice to just have it be longer by default. So I'll just extend it, let's say, till 1,000 units away. And I will add a PCG component. And on the right here, I will add the graph we just created. And that's all we need here. At this point, I can drag out the PCG fence and we can get started with setting everything up. So let's go ahead and open up the PCG graph. The first thing we need to do, of course, is get the spline information. So we're going to right click and search for get spline data. And already we need to add the grammar that we're going to be using. So if I deselect the get spline data, on the right here in the parameters, I can add a new parameter. We can change the type here to string. I'll rename it to grammar. Now, depending on the result you want, your grammar will be very different. But I'm not going to go over the grammar syntax in this video, as I already covered it when I did my previous grammar video, which you can check out right here if you have not seen it. I recommend watching it first so you understand the grammar syntax. I have the actual pillar. Then I have this kind of intricate railing. And then I'll have another pillar, and this is going to just repeat over and over and over. And then we'll go ahead and add a pillar, a gate, another pillar, and then again, I want this to repeat over and over and over. So this is the kind of result we're going to get, but of course, in a nicer version. So the grammar we're going to be using is this right here. We're going to go pillar and railing. This is the one for specifically the pillar for the railing. Then we're going to close it off with a pillar. Then we're going to do pillar B, which is the big one for the gate, and then we're going to close it off with it. And then we're going to do, again, pillar railing, and then close it off with a pillar whenever the end is. So that is going to be our grammar. So now that we have the grammar, I can right-click and search for get grammar. We can drag out of get spline data, and we can search for add attribute. Now, by default, it selects the math operation. We want the parameter version, the add attribute under param, and then we can plug grammar right into attributes. In the add attribute detail panel, we want to change the output target to be grammar, because this is going to be the attribute name that we're going to be using. So at this point, we have the grammar put in, we have the spline. How do we now get the meshes attached to the spline? Well, we're going to be using the same method as it is in the sample project. And I'll go ahead and explain what it's actually doing. Assuming you have the engine and plugin content turned on here under settings, engine content, plugin content, you can go under procedural content generation, sample content, grammar, and then grammar sample to open that level up. And what we want is this building's information. So if you select the building and scroll down to PCG, we can open up the PCG graph that it has. And I'm going to explain everything in our version, but we need a few things from here. And the things we want from here is this extract mesh info, the add attribute, and these variables. And we'll also need this section right here, but we'll go ahead and simplify things in our version, and I'll explain why we're getting this all as I do. I'm going to copy it all and just paste it down here. At this point, this is no longer needed. I'll go ahead and close out of it. The thing we wanted, though, is this right here. Now, we don't have this mesh info and module info variables. So we need to go ahead and add those. So I'll go ahead and deselect everything. I'll go ahead and add a new parameter. I will rename it to module info. And when I do, you'll notice that these get disconnected because they realize, oh, we don't know what this is. So everything gets disconnected. And that is fine. The module info type is going to be PCG subdivision submodule type. This one right here. When you open it, you'll see symbol, size, scalable, and debug color. But we want this to be an array. So we'll go ahead and change it to an array. And then the next thing we're going to need is all our static meshes. So we're going to make a new variable, rename this to mesh info, just to keep it consistent with how it was in the other demo. You could absolutely name this something differently. And the type here will be static mesh object reference. And just like the other one, it will be an array. At this point, I'm going to rehook up module info into the in and mesh info into the attributes. So what does all of this do? Well, first of all, the module info, as I showed before, if I press plus and add one, you can see we get the symbol, which is going to be the actual grammar symbol here. For example, pillar is a symbol, railing is a symbol, pillar B, gate, all of these are symbols. Then we have the size of it in case we wanted to control the size from here, whether or not it is scalable, so whether or not we wanted to adjust automatically in the size to fit our spline. We will have one of these to be scalable to make sure that it always fits. And then we have the debug color in case we want to change the debug color to be something more specific, so we know which one is being debugged how. Of course, our mesh info is going to contain the meshes. So at this point, what we need to do is add all of our mesh info to this module info and all our static meshes to the mesh info here. I have 4 total modules I'll be using. So I'll go ahead and add the 4 here, and I'll fill in the names of the symbols. For example, pillar, pillar B, railing, and the gate. Now, you want to make sure you keep a note of this order because we'll need to recreate the exact same order in the mesh info. But before we go there, a couple of things. Normally, you can put in the size here, and this is the size of this section. The way we're doing it, which is using this extract mesh info, it's actually going to be using the size of the mesh automatically. So it doesn't matter what you put in here, it will just work, which is awesome. But what we do want to do is say that the railing itself will be scalable. So that way it will adjust automatically in length to make sure everything fits in here nice and well. And then under mesh info, we'll go ahead and add 4 inputs here. And then just like the previous one, pillar, pillar B, railing, gate. Meshes are plugged in and they match, so they will go ahead and combine, which is what happens in this add attribute. Now, what does this extract mesh info do? It is a subgraph that is given to us automatically, so we can go ahead and use it. Attribute renamed to mesh, all it does is make sure basically that no matter what your attribute was called before, it is now renamed to mesh. So that way, when you're using the static mesh spawner, it is now going to be using the attribute mesh instead of fence number 2 that is pink to the right side that you named specifically to know what that version is. It makes it a little bit easier down the line, which is great for us. After this, it just makes sure that it is supporting both attributes and points in case you plugged in attributes instead of point information. It gets the bounds from the mesh. And again, here it specifies the attribute name as mesh, so it knows which ones to get. And then it basically sets the bounds to be the size of the mesh. This is the local center. The local center, you will not find in the information at the bottom when you press A. And all it is the bounds min plus the bounds max divided by 2. It is the center of your point. And so we're storing the inverse of the center as our pivot offset. And now we have access to a pivot offset, so we know how far it's moved. And then we can have all this information for free thanks to it being provided to us from the subgraph automatically. Just make sure you don't modify this version, as it does come from the plugins directory. If you do want to make changes, make sure you make a copy and make changes in that version. So that's great. So we got the bounds now matching the mesh. It put the pivot in the right place. This is all good. So now what do we do from here? Well, at this point, we can just drag out of add attribute and search for subdivide spline. And we want to use this right here. Now, subdivide spline is a new grammar node that basically subdivides the spline into sections based on your grammar. And it'll automatically do all the calculations for us, assuming that we feed it the right information. So a few things we can do here. In the detail panel, we want to use grammar as an attribute, so we'll go ahead and check that on. And instead of last, I will specify grammar as our attribute. Now, it's giving us a warning right away. There's unmatched token found in grammar, pillar, railing, pillar B, and gate. That's because we have not specified the module's information. Now, we can go ahead and add the information in here the same for information as we had before. You can see there's a symbol, size, scalable, debug color, all of this nice stuff that we already plugged in here. But because we've plugged it in, we can now use module info as input. So I'll go ahead and just check that on. Once we turn on the module info as input, you'll see we have the module info as an input we can plug in. So we drag it in and we get a warning. What is this warning? The Spline has incomplete subdivision. Grammar doesn't fit the whole segment. Well, that is odd because in our module info, we have clearly specified that railing is scalable. So what do you mean it doesn't fit? It should automatically scale to it. Well, here's the thing. This scalable and the scalable that it's looking for is different. If I open up the attribute names for module info, it says scalable attribute name scalable. Now, you might look at that and be like, okay, everything matches, everything's good. Well, if you check this on, it gives you an error now, which is unmatched token for everything. Attribute scalable was not found. And that's because what it wants is be scalable. And once you do that, it no longer complains. In fact, if we now debug this with D, you will see here all of the points. And you can see that you actually get the outline of all the different points. You can see that's where the pillar is going to go, the railing, the pillar, etc. It's going to go all the way through and take care of everything we need. So this is just something to watch out for. This be scalable, if you're using the information from here, it's not scalable, it is be scalable. And you can see that when you press A on the add attribute down below, you can see we have the symbol, the size, and then it's a be scalable right here. So that is why it is incompatible. Now, why is it be scalable in one and scalable in the other by default? I don't know. Personally, I would keep it consistent so that way it just works right out of the bag, but it is what it is. Just keep in mind, be scalable versus scalable. You got to match both of them, so make them both be scalable. Now, from here in the original, it was going to match and set attributes, and then it was doing a bunch of math to make sure it was placed in the right direction. Now, this match and set attributes we don't actually need, because in this subdivide spline, there's a nifty little checkbox under extra output attributes. We can specify forward attributes for module info. So if I press A here, I get a bunch of information, but it ends here after grammar and then symbol. If I check forward attributes and I turn that on, you will see that all the information that we had before, we now have passed all the way through. The pivot options, the extends, the mesh, everything's pass through, just like you would if you were to use just a match and set attributes. You could absolutely just do this right here and not have the attribute and then uncheck the forward. And then if you press A on this one, you'll get the exact same information just with an extra node. So if for whatever reason you need the original information minus all this information, then have them as two separate nodes. But in our case, we kind of want them all combined. So I'll go ahead and turn on forward attributes from module info and have that turned on. You can also turn on the debug color attribute name here if you'd like, if you went ahead and set up the debug colors in your module info. So what I can do is change the debug color in all of these. Now it's not going to show it by default. So what we can do here, if we drag out of here, we can search for set attribute and we will make sure that this subdivide spline is plugged into both in A and in B. We want to set the color and we want to set it from our debug color, which is this one right here. So you can even copy it if you're unsure how it's spelled, just paste it in. And then when we go ahead and debug it, we can use a material override. We can go ahead and override it. Now, I don't see all the other stuff. To show it all, I'll hit this icon right here, the little cogwheel, and I want to make sure the engine content and the plugin content is enabled. And now I can search for PCG underscore debug material underscore color. I want this one right over here, PCG debug material color. And now if we take a look, you can see, well, it looks exactly like I'd want, right? We have the pillars, everything seems to be connected, and you can see it has all the colors I've set up here. So wonderful. So we know this part is working. Now I'm gonna remove this debug. You don't actually need it, but just in case, I'll just move it up here so I don't need to get the material again. So now, how does this work? Well, it's simple. I can just use all of the math that they've already done for us. And again, we don't need the match and set attributes, so I'll hold control and just plug it in into the set right before it, and we'll get rid of that. And after it does the math, which is just scaling it in Z, because it's based off the module height, which is plugged in right over here, it then offsets the pivot accordingly and makes sure that it fits inside of the bounds we basically specified using grammar. So after all this, we can just drag out, let's search for static mesh spawner, change the mesh selector type from weighted to by attribute, and the attribute will be mesh. And just like that, you will see we have exactly what we wanted. But aside from it being exactly what we want, which is we have the railing all going along, then we have these pieces, then we have the gate, it's all the same height, and we can't really control it easily right now. We have to go to the graph. So let's go ahead and make sure we can do a few things. One, I want to be able to control the height of it. Keep it all consistent, but I want to control the height. Two, I want to be able to return to the original height of the objects, whatever that was. So that way, I'm only using grammar to spread the points along the spline in the manner that I want, but the height will be always the original height. So that's control 2 that I want. I also want to be able to use the module height and adjust it up and down, but then maybe specify that for certain pieces, I want it to be bigger or smaller than the module height relative. So I want to scale it per object as well. And lastly, for number 4, I want to make sure that I can flip the entire thing in case I'm using models that have no backside and they're kind of facing the wrong way based on the way I've placed the curve. There's a lot of stuff, but don't worry, I'll guide you through all of it and explain along the way. We'll start with exposing the module height so we can control it dynamically. To do that will be relatively simple. With nothing selected, we'll go ahead and add a new parameter. We'll go ahead and rename it to module height, and I'll set it to be 100 by default. And now we just need to add the attribute. So we'll do that right after this grammar, or you can do it right before, it doesn't matter. I'll duplicate the add attribute and then plug it in between. In the add attribute, we of course want to change the output target to be module height. And we'll go ahead and right click and search for get module height, and we'll plug that into the attributes. So fantastic, we now have information for this. So now in the subdivide spline, we can use module height as attribute. We check that on instead of last, because in case we put something else right after this add attribute, it will work right now, but it's good practice to just type in the correct one, which is module height, exactly how we called it. And now with our graph selected, I can go to PCG, open the parameter overrides, go to module height and change this to 200. And you'll see everything goes ahead and scales accordingly. You change it to 150, 100, whatever we'd like. So fantastic. So this is working how I'd want, but now I'm looking at it. Well, we want these to be taller, right? We want to be able to control the height of these and say these are twice as tall than the rest. So all we need to do is add another variable to control the scale. Now, a lot of this stuff, the module info, the mesh info, the scale, all of this could be condensed into either a data table or a data asset that you can just use directly in here. I'm just doing the simple versions, but I do have a video on data assets if you're looking to learn how to use those in PCG as well. So again, with nothing selected, I'll go ahead and add a new parameter. This is going to be of a type float. We're going to rename it to height scale, and I will go ahead and make sure that it is set to an array, and I'll add the same number of inputs as I had in the module info and the mesh info. I'll make sure that it is 1 by default for all of them, and just keep in mind that it is going to be related to each one of these. So index 0 here is the same as index 0 here. Now hooking it up is relatively simple. I'll just go ahead and move this over to the left a bit, and again get an add attribute from the parameter section, and plug that into the modules info and disconnect the other one. And then go ahead and right click and search for get scale for get height scale. Plug that into the attributes. And of course, in the add attribute, we want to change the output target to height scale. So now if in this subdivide spline, I can already press A. And if I scroll to the right, you'll see height scale. It is passing all the information through because again, we've turned on forward attributes from module info. So we're getting all that information passed through. So now how do we scale it? Well, we need to modify the information in here. Now there is probably a better way to do this, but this is just the math that I found that works for me, and it's not very complicated, which is great. The first node here divides the extents z by extents z that we have saved before, and it outputs that into the scale. So this is what controls the height relative to the actual modules that we're setting up, the module height. So this is what we need to modify. So what I'm going to do is drag all of this a bit to the right. Then I'm going to right click and search for divide, because we need to grab a new divide node. And we need to get the same information as before. From the set node, we'll plug in both to A and into B. So what we want to divide is the extent z that we have saved, extent z, by the new scale that we have set up, which is height scale. So extent z and height scale. As you recall, in here is where we've added in the extent z, which is the original mesh's extents. So that's where we're getting the information from. And then in B, instead of the original, I'm going to plug this in. So plug that in, attach the new one. And now if we take a look, nothing has changed. And nothing has changed because everything is still at 1. If I go ahead and check on height scale, and then I'll set index 1 to 2, you will see it gets bigger. 3, it gets bigger still. It also gets bigger down below. Because of the center offset, basically, it is now scaling it not from the original pivot, it is scaling it from the middle of the object. So we need to compensate for this by offsetting it back upwards. So after it's done all of the computations here, we'll add a little bit more right here at the end. What we want to do is just drag out of the out, search for add. We want to add attribute, and that's going to go before the static mesh spawner. And we want to basically plug in whatever we're plugging in here into position.z. So I'll go hit the plus button, select position, and just type in .z at the very end to offset it just in the z axis by whatever we plug into in B. And we're basically doing it off of the height information and the scale information. We have the two things, so we should use those. So from this add node on the left, I'll drag out and search for point to attribute to get our point to attribute set conversion. So we get rid of all of the point information that it was before. We just keep the attributes. And from here, we'll go ahead and use a multiply node, and we'll have it plugged into A and B. And all we want to do is for their inputs specify module height and height scale. Now I went ahead and make sure to copy it because typing it in, you could get mistakes, but if you get a mistake, it'll tell you that it doesn't exist, and in which case, just go ahead and copy it over. If we were to add this in as is, you will see it is overcompensating. It is moving things up way too much. So first of all, it's moving things up double as it's supposed to. So from this multiply, I will search for a divide node, and then out of NB, I'll drag out a search for create attribute, and I will specify just 2 in our value, so it goes ahead and divides it by 2, and now you'll see, well, they now line up. So that's great. But they're still off of the ground, so we need to put it back down by half of the module height that we had before. So from this divide, I'll drag out and search for subtract, and this subtract is what's going to go into NB, and what I want to subtract is half of this value. So I'll duplicate the divide node one more time. The out from the original divide will go into NA, the 2 will go into NB, so that way we don't need to create a new create attributes node, and that is going to go into NB of the subtract node. Now if we take a look at it already, well, what's wrong? Why is it not subtracting what it's supposed to? Well, that's simple. Inside of the subtract and divide nodes, we have everything left on last, which means whatever the last attribute it was using is what it will be dividing and subtracting with. So we need to modify this. In the divide node, this second one on the bottom, we want the input source to be module height. And then in the subtract, we want the bottom one specifically to be module height, because we're taking module height and dividing that by 2 and making sure that we get in module height again from here. So these divide and subtract are good, but on the multiply, we also want to change something because in our case, this multiplication, we're overriding onto module height and we don't want that. We want it as a new output that the divide is using. So I'll go ahead and rename the output target to scaled height. And that is the last thing. So the multiply, the divide, and the subtract here all get custom things in their input/output targets. And when you have everything plugged in just right, you'll see that we now have the actual pillars here taller. And if we come closer to get a better view, we can change these now to be too high. We can adjust the gate now to be taller. So if we want a nice taller gate, and it's all modified by the module height. So if I set this to 200, everything gets twice as tall. It is all relative. So if I wanted actually to be all short, but these ones to be, again, still twice as tall, I can adjust it as needed. So that's awesome. We now have this set up. Now, let's go ahead and work on being able to flip this to the other side in case this was a one-sided mesh, because that is relatively simple. And then I will show you how to keep the original height no matter what it is, so you don't need to worry about the module height information. To be able to flip it, we'll make use of a new node called Spline direction. And the operations here are reverse, force clockwise, and force counterclockwise. Now it has no inputs, unfortunately. So what we can do is with nothing selected, add a new parameter as before, change the type to a Boolean, and rename it to clockwise. And now what we can do is just use a branch. Right click, search for branch, open it up, and then right click and get clockwise and plug that to output to B. We'll plug that in right after the get spline data, and then we'll just use 2 spline directions. Now, true for this branch will be B, so that means that counterclockwise will be above, and the one below will be set to clockwise. So put output A into the counterclockwise, and output B will go clockwise. Now, it does do a conversion here, and honestly, I don't know why, because as you can see, it is the same type, but for whatever reason, it thinks it's a wildcard. I'm sure that's something that's going to be adjusted later. And then both of these just go into the add grammar here. And now if I go in here and check on clockwise and not clockwise, you'll see it goes ahead and flips it. in the other direction. That's a little hard to see on this one because it is a 360-degree meshes for all of these, but if you did not have one of the sides and you accidentally curved it in one direction and now they're facing inwards versus outwards, this is an easy way of going ahead and flipping it. So fantastic. This is all working great. So now how do we make it so we can retain the original height in case we want to use Grammar to just spawn our things in the right size, but keep everything as it was? Well, that means we need to modify this back section here. So again, with nothing selected, I'll go ahead and add another parameter, and I'll go ahead and rename this to original height. And I will change the type to a Boolean. It'll be off by default. So after this attribute set where we set the debug color, I'm going to right click and search for a branch. Again, open it up, right click and search for get original height and plug that into output B. And now I'll hold control and take this output and plug this into output A and plug this in right after the set node. So by default, with everything off, it will still do everything as it was. But now, if it's true, if we want the original height, what do we do? Well, we're still going to make use of the nodes here, but just a little bit differently. I'm going to take 3 of these. The pivot offset used to be scale 2 and rotated and added to the position. We're grabbing these minus the scaling in Z accordingly because we're doing that manually. So let's duplicate them down here. Output to B will be plugged into the multiply in A and in B, but a few things will be changing. And that is this add node. We'll go ahead and move all the way to the right because we need to do some things in between here. Now, everything's kind of says disabled, but that's because in our graph that we're sampling, it is disabled by default here. So if I turn this on, everything will go away because we haven't finished the graph yet. But now the top says disabled, and then the bottom, we actually see that it's all going through, so we can read the information from it easy peasy. Effectively, what we're changing here is the pivot offset that we've computed before because we need to adjust that. So from here, from the transform direction, I will drag out and search for set attribute. And then it's going to go before this and added to the position node, the add node. And just like before, though, it is going to go plug into in A and in B. The set node in the input source A will be the position offset. So we're setting the position offset with whatever we plug into the last section. So what do we want to do? Well, it's simple. We drag out and use a delete attributes node. And I want to basically only keep all these selected attributes under operation, the pivot offset. I wanted to get rid of everything else. So if I press A on this, you'll see it has all the information of the default points plus pivot offset and nothing else. If I pressed A on the vector here, you'll see we get tons of other information that we don't need. This gets us just the pivot offset at the end. From here, I can drag out and search for break and break vector attribute. Now, because we have specified pivot offset here, and it is saying input source last, we're only getting the pivot offset here. What we can do, though, if you'd like, is get rid of those delete attributes entirely. And that is by plugging it all the way through. Instead of last, we specify pivot offset. So we can actually get rid of this now. So by specifying input source pivot offset, we can just break that specifically without the node. I wanted to show that you can indeed just grab the section you want. In case you want to convert it to an attribute, it will just be then the pivot offset inside of the attribute. Because there's a few different ways of doing this. So now what we want to do is drag out and search for make vector attribute. In the make vector attribute, we want to specify it's going to be an output type vector, which is a 3-value vector. X will go into X, Y will go into the Y, but the Z is what we're changing here. So I'm going to right click and search for module height, which is our module height of the entire thing. And we want to multiply this by -half. So I'll do a create attribute node and type in -0.5 in the value because we want it to be halved and then inverted so it moves down, not up. And the output of this will go into Z, and then the output of the vector attribute will go into in B. I actually typed in position offset instead of pivot offset, so I'll go ahead and correct that on the set node, and now we're good. No more error. So it has all of this math, great. So after this, well, that's it, actually. We just plug it into this static mesh spawner node. And now you'll see it is the original height of the mesh. In fact, if I drag out the original mesh, you can see right there, the exact same height. Everything now has the original height that it came with. Now, this version doesn't allow you to scale, but with the things I've shown you already, you should be able to set that up yourself. But the main thing is we have now a grammar spline, or we can go ahead and have it be the original height, be a custom height, control the scale for every individual one if we want it to be custom, scale the entire thing overall or down, whatever we'd like, flip the direction, and if we want to, we can even change the grammar, or if I wanted to, I could say, you know what, actually, I want 2 pillars at the end, and now you'll see it automatically updates to be 2 pillars at the end. So as you can see, Grammar is extremely powerful, and with these few little tweaks, it should give you enough of a baseline to start using it in your projects now that you're able to spawn things around in the height you want to keep it consistent, or in the original height, or any which way. Now, there's still a lot of things to cover. For example, one thing you might have noticed is right over here on this gate, it does not touch all the way. And that is because the size of this bounding box effectively goes over here. So that's why this gate piece ends early. And that's something we'll be addressing in a future video. So if you're interested to see that, make sure to subscribe to the channel. And of course, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join our community, the link to the Discord will be down below as always. And if you're interested in learning more cool PCG tools that I've created, check out this video right over here where I show you some of my favorites.